Okay, hello, welcome to this session which I'll be covering on unit testing using control flow graphs. So before we move into the topic in itself, I'll be briefly covering on the significance of testing, and then basically the terminologies verification and validation, which are often used with respect to software testing. Discuss overall the concept of testing in the software development process, focusing on unit testing in specification, and finally moving into the usage of control flow graphs in white box testing. As you can see, the overall objective of testing a software is basically uncovering as many errors as possible. So we would like to verify whether a software product matches its requirement specifications. Thirdly, we would like to validate the quality of the software by using minimum cost and effort, and this is exactly where we need to optimize our resources. And when I'm talking about optimizing my resources, I'm talking about usually testing software of size, say 100 programs or 100 modules, and we do have restrictions or constraints on our like the resource limitations. So we need to optimize what kind of resources or which are the areas which should be prioritized when I move into testing those entire software. And finally, the objective is to perform effective tests and issue correct problem reports. It's useless to generate a huge report wherein the exact point is not indicated. These two terms, verification and validation, are often interchangeably used, but the actual meaning is basically, in case of verification, we would like to say, are we building the product right? That means we are focusing our entire set of activities in trying to ascertain whether the processes that go into building the product is correct or not. Whereas in case of validation, we would like to highlight, are we building the right product? That means even though we follow the correct processes, at the end, whatever we deliver, is it what the client needs? Is it traceable, or is it going to meet all the customer requirements? That is very important. So once we ascertain these two throughout our entire testing process, we can dig deeper and try to understand the first phase of testing, called the unit testing. The name unit testing comes from the fact that we are testing the basic unit or the first functional unit of a entire software. In most typical cases, actually a program is a block of code, and that is the unit that needs to be tested. Now that can be tested in two ways. One way is the white box testing, in which we know the internal logic. So I would like to highlight this. This is the internal logic that can be understood or that is known, and this is the white box testing, and the second is the black box testing, where we don't know anything about the internals. Basically, we give a set of inputs and we try to judge the functionality based on the set of outputs that we get here. Okay, so in this case, in this particular session, we are interested in understanding whether my internal logic or the data structure that I have developed is performing correctly or not. So I have this part open to me. So it's a white box testing. The technique that is used is control flow graph, and as the name suggests, it is basically a graph, and like any other graph, it is comprises of nodes and edges. There are different kinds of nodes. It is a directed graph, so the nodes are of three kinds. Sorry for the misplacement. The nodes are basically of three types. One is the statement node. The second is the nodes which are created having multiple branches. It can be due to if, it can be due to loops also. And there are edges formed between the nodes based on how the control in the program is flowing, or how the flow of control can possibly flow. It's relatively easy to map the standard constructs from the program languages to the elements of CFGs. So let us take an example and let's see how the blocks look like. A sequential statement block will typically look in a CFG like this. It is a simple arrow flowing in, the statement will be executed, and the control will be passed to the next block of code. So it's a linear kind of a structure. Whereas if we see an if statement C, or if the condition C is true, then execute S1, else execute S2, which means that the graph will look somewhat like this. This is my conditional statement C. If this is executed and if it is found true, it will move into this block and execute S1 and finally go out of the if statement, or otherwise if it is found false, it will execute this branch, execute the statement S2 and move outside the if block. So as we can see, for any kind of if statement there are true paths and there are false paths. So there are two paths for every node, and this node is also called a predicate node because it has a branch out. Same way, if I have a multiple if statement in terms of a switch case statement, the condition C is getting executed, and based on the case, whatever is there in C, it can either follow S1 or S2 or many other branches and move into Sn before it end case in the last statement. So it is typically a multiple branch statement. Here we have another kind of if statement where there is no else statement. So if there is only one path, if condition is true, then execute S1, otherwise exit out. So here again, this condition, if it is true, it will move into this branch, execute the statement and move here. Otherwise, it will be simply traversing out of the if block. Likewise, this is how the constructs will look alike in case of loops or basically multiple iterative kind of a statement in any procedural program. Suppose the block is while loop. So we have a while condition. If the condition is true, do statement S n number of times and then exit out. So the condition is tested first. If it is true, it will go in here, execute S, come out, and then it will check the flag condition. If the loop exit condition is not yet reached, it will move back iteratively and it will execute C, check C rather again, and then move into the true path again. And then this block will be executed multiple times. Once the condition is rendered false, it will exit out. Or even if it is false in the first attempt, it will just traverse this path. That is the false path. This is a for loop. In the for loop again, we have an initial condition, say I is set to 1. And then I enter the loop where this is the statement which is executed. And then we have the condition I less than equal to n. If it is yes, I traverse back and execute S. If it is no, I exit out of the loop. So if this is the construct for I equal to n to 1 to n do S, this would be how the CFG will look like. And likewise, we have another do until loop statement. So it's very similar in both the cases for if as well as for while. We have multiple branches. Except for sequential statement, we have a single linear path. So once you get a piece of code, the first priority is to number the statements, and then based on the kind of statements, we have to construct the entire graph. So for example, this is the example that we have taken. This is the beginning path or the beginning node. From here it traverses simply. From here it branches out and executes C and then comes back to 2. Here, as we can see, there is a loop condition. So if it is true, it moves in here and then does the statements. Here there is a nested loop, so it is a loop inside a loop, and then finally it exits out in 7. The piece of code has not been shown for brevity, but the entire graph structure can be easily understood by seeing that here there is a basically here this is a if statement without an else. Here there is a bigger outer loop, and here there is an inner loop. So it is a nested loop. Once we draw the graph, the next job is to find out what are the different ways this graph can be traversed from beginning to end. That means we are trying to ascertain the minimum number of paths from beginning to end, which will essentially constitute or help us in developing the test cases for testing our software. The simple formula given by Maccabi, who proposed this graph in the first place in 1972, is called cyclomatic complexity, and it is given by several formulas. One of the formula is basically trying to understand how many regions are bounded or how many closed regions are there, and simply add 1 to that to get the total cyclomatic complexity. Or otherwise, we can also find out total number of edges. In this case, we have 9. Total number of nodes, in this case it is 7, And then the calculation of Vg is based on the formula E minus n plus 2, or that is 9 minus 7 plus 2, that is 4. Okay, so once we get the cyclomatic complexity, it helps us in finding out the path of traversal. As we can see, we can navigate all these paths from beginning till end, and essentially these will help us to formulate the test paths to identify the test cases in the software. So thank you, hope you have enjoyed.